Kia ora everyone, here is the TGC derived grade exam for Level 3 Chemistry in 2024. This is the organic paper and this is question 2. Recalling question 2, there are 3 main parts to it, and the first 2 are our techniques in organic, which are distillation and reflux. So it is really good that you understand both of these. One is bound to come up, maybe both. So there's a lot of context setting here. We really just need to focus in on the main bits. We do have some boiling points in the question, so they are going to be useful. There was a little bit of an error here. Most of you figured out that that should have been an arrow. Apologies for that. Don't know how that got through. This is the reaction, so that's what we need to focus on. But really, what we're doing is we're going to scroll through and we're going to see why do we need to heat under reflux in step 2. So basically, step 1, we put some sodium bromide and some butanol. And if you look at that, it's like, why is there sodium bromide? There's no sodium bromide in there, but actually it's just a way of generating HBr, because that's a little bit of a tricky substance. So we've now got some HBr and we've got some butanol, and so that's going to enable the reaction to take place. Once we've generated the reactants, we want to reflux it. So why is reflux necessary? Now, it's not quite set out like it was in level 2, where you had lots and lots of bullet points. Sometimes there's bullet points in level 3. But if you're asked a question about reflux, let's start with what reflux is. So reflux allows us to heat a reaction up. And we want to say why we want to do this: to speed it up. So that's really important. That is the why. Without losing volatile compounds, and this can be reactants or products in the process. Okay, so that's our general statement. So in this case, you notice where you're saying in this case a lot. In this case, the reaction between butan-1-ol and HBr can react in any butan-1-ol or the product 1-bromobutane, or in fact HBr to be fair, but we'll just concentrate on the organic compounds here. Any butan-1-ol or bromobutane that evaporates, I'm going to say boils, because it actually should be boils and not evaporates. And we can have a little discussion about that at some stage, but remembering that water boils at 100 degrees, but it's not 100 degrees when a puddle evaporates. So there is a difference between boiling and evaporation. So, and we're talking about their boiling points in this situation. That boils, and so we're just going to go liquid to gas. The gas particles rise up into the condenser. So it's really important to talk about how this happens as well. The continuous water in the outer tube cools, I should say continuous water flow is probably better, and the outer tube cools the gas so it condenses back to a liquid and drips back into the flask. And what we want to say here, probably the best thing, is to continue to react, or so if it's a product, it's not lost. Okay, so people tended to focus on one or the other, and it really is everything is contained. The other thing is, please don't talk about single molecules as well. We're talking about, when you're talking about a gas, you're talking about a lot of separated particles. In this case, they are molecules. But individual molecules kind of can't really be a gas. It's just one molecule. So whatever temperature it is, one molecule is one molecule, if you have a little think about that. Anyway, so that's reflux. That was only I can't remember if I put that to an excellence or not. Let me just check that. Either a merit or an excellence there. Let me just have a quick check at what I put that to. Question 2, no, only a merit. Okay, so over here to distillation, I've got a couple of bullet points here. The purpose of the process and how it produces a sample of liquid 1-bromobutane. So distillation allows the separation of compounds based on their boiling points. Okay, so as soon as we say that, we need to include the boiling points. So relevant boiling points are really 1-bromobutane is, to state this here, 102 degrees Celsius. Now just note that's really close to the boiling point of water, so you can't really separate effectively something at 100 degrees and something at 102, so that is a bit of an issue. Butane 1-ol is 118 degrees Celsius, so just so that we've got those there. Okay, so we have the reaction. Okay, remaining mixture. Okay, the reaction has occurred in the flask. We could have a mixture of reactants and products. In fact, we are likely to have a mixture of unreacted reactants, even though we've refluxed, and products. It could be unused reactant. And of course, we've got 2 products. So the temperature is set to above 102 degrees. So at this, it has to be above 102 degrees. But that does mean that water is going to boil off as well. However, there is probably another step we could take if you're worried about separating those, and that would be using a separating flask, because water is polar and 1-bromobutane is not going to be very miscible with water. So anyway, the temperature is set to above 102 degrees. 1-bromobutane, let's just focus on that, will boil, and the gas particles rise into the condenser. The condenser is arranged so that when the gas particles hit the cooling jacket, they condense to a liquid, and the tube is sloped away from the flask so that 1-bromobutane can be separated and collected. Probably separated from the mixture and separated and collected. Right, so just double checking, have I got the purpose? Yes, separation based on boiling points. And have I done how? Yes, I have. So that question is an E. If you want to add a bit of extra in there, you could just quickly address these boiling points. So butane 1-ol forms hydrogen bonds. So that's why it's a bit higher, and we've got no hydrogen bonds there. Okay, they've got a similar. In fact, 1-bromobutane's got a higher molar mass than butane 1-ol. Thinking back to bonding, they all do kind of interlink. So that's the second part of question 2. The final part was a bit tricky, but I was really proud of how many of you got all or some of this right. So I did add in this really weird 3 moles to 1 mole, and that was to try and alert you to the fact that there was 3 points on this molecule that an acyl chloride could condense with. So we've got a CH3COCl reacting in there, a CH3COCl reacting in there and a CH3COCl reacting with that. So we're making 2 esters and an amide here. That was really the tricky bit there, and it's also drawn oddly. So I'm actually just going to draw it out. We've actually got a prop here, it's propane, so I'm just actually going to draw prop here, and I've got carbon, doesn't really matter which order I do it in, but carbon 1's got an alcohol, and so has carbon 3, and carbon 2 has got an amine. So I'm just going to draw it out like that just to make it a bit easier. And remembering what we're seeing is we've got an OH group and a COCl, and we are doing 3 condensation reactions where we're removing HCl. So here we are going to have an ester group, and that is a CH3. Here we are going to, have another ester group. Okay, and then that will be an H2. We'll have an H there, and then for the NH2 we're going to remove an H, and we're going to make an amide group. Sorry, that's drawn pretty badly. So I just go and double check all my carbons have got 4 bonds, because you'd be silly not to. And then there's our answer there. What we do have to do is justify by identifying the functional groups and the type of reaction. So we've got condensation. You can see condensation is very important, where 2 molecules are joined with the removal of a small molecule. So this is the second time we've had to say that in this exam. In this case, we've got HCl being removed. So 2 ester groups, 2 ester links form on C1 and C2, where the Cl from CH3COCl and an H from the alcohol group are removed. And 2 condensations. Okay, so I've said the ester links are formed. Okay, and then 1 amide link forms on C2, C1 and C3, that should be up there, on C2, where the Cl from CH3COCl and an H from the amine are removed in 1 condensation reaction. Something like that. That was another E question. So that was a tricky question, but actually, as I said, those of you who did this actually did a really good job on that, and so I'm really proud of the way that you are thinking through this. So great job, team, and I'll be back with question 3 in a mo.